Okay, so welcome back, and we are in Chapter 7, the second day in Section 4. So in Section 4, what we've talked about already are relations and functions. Go ahead and scoot over since that's available. So you are, looks like pretty strong with relations and functions. We defined that even yesterday. We looked at that before we accepted homework. And so today we're going to use that idea to write equations for functions. Which, another way to say that would be to write the what? Begins with an R. We have them in sports. The rule. Write the rule for the set of points. Or write the equation. And so a rule is a function because for every input you get exactly one output. Okay? A linear function would be the function of what kind of a graph? What would it look like? The graph of a linear function looks like, Brandon? A line, okay? So do you remember our favorite form? That model of a line? Y equals, can you say it? Y equals
mx plus b.
Good job. That was slope-intercept. We'll keep coming back to that again and again. Okay, so in that model equation for lines, we have three things. We have to keep reviewing that so we can remember. M represents something. B represents something. And then X, Y together make an ordered pair. So they are what is an ordered pair on a graph? A point, good. And how many points would be on a line?
2.
How many points could be on a line?
Oh, a lot.
A lot. Infinite. I mean, a lot, by definition, a line doesn't end, right? If it's a line segment, it might have endpoints, but lines don't end. So X, Y in the equation have infinite possibilities, but M and B stay the same for a given equation, right? For a given line. And can you say what M represents in a line? M is the
slope.
Good. And B is the
y-intercept.
Good. So those don't change. The y-intercept will always be in that one place on the y-axis, right? And the slope will always be the same for a given line. Okay. So today we are going to write linear equations when you're given a bunch of points. You got to figure out the two things that never change, which I just said were which two things? The slope and the y-intercept. Okay. So we're going to write a linear function rule today. A short lesson and then lots of practice for you. Okay. We are going to write equations for lines. We just identified we need to know the two constant things, the slope and the y-intercept, right? So let's go ahead and we'll start with our form. So you're going to box this up. This is your plan today. Start with your form for linear equations, slope-intercept form. And then we've got to find those two things, right? So let's start with the first thing that we see if we read this left to right. Let's start with slope. How does a person find slope? Do you remember how to find slope? There was a special equation, right? Because slope has to do with the rise over the what? Run. So how much does it go up? How much does it go over? Left to right. It's always best to go left to right if you can, right? So do you remember the equation? M equals y2 minus y1. Good.
Over x2 minus
x1. Okay, so all you need are 2 points, and you simply make sure that you have the ordered pair x under y, x under y. You have 2 points carefully substituted into this little formula. Let's use. Now, if you had a graph, you could just start at a left point and move to a right point and say, how far did I go up? How far did I run? How far did I rise? How far did I run, right? But this would be if you were just given points, ordered pairs. And then finally we need to find our B, right? Finding B. How does a person find B? what do all b's have in common? And you had to be able to find this on your test. Some of you sailed through quickly and some of you got stuck a little bit. How do you find a y-intercept? All y-intercepts have something that is the same. Look at the graph. If you are a y-intercept, you're somewhere here, right, on the y-axis. And so what do all points have in common? I mean, they're on the y-axis, but what
They have zero.
else can we say? Casey,
They have zero.
zero where?
On the X.
On the x, good. Their x value is 0. So we can use 0 and find the y, right, to find it. There's another method that we can use too, and that would be use another known point. If you see this point, you got your y-intercept. Grab the y. If not, we can use another point that is not the y-intercept to find the y-intercept. And that's what we're going to practice in a moment by substitution. And don't forget to pause the video if you need to take something down. Make sure you have your notes down, you understand them. Okay? Okay, so we're going to write a rule for this function. Here's a table. We have 4 ordered pairs. We're going to write the rule for this. So you're going to have to take it down, freeze it, take it down. Okay, so we're going to write a rule for this function. So the first thing we want to do is say, is there a pattern in the domain, the x values? Is there a pattern?
Yes.
What is the change?
+1.
+1, right? +1. So constant change. And then how about in the y values as we go left to right? What is the change? +1, +1. Okay? So we have a linear function because we are adding the same value to our output every time. That is how we know we have a linear function, okay? So we can write down our model, y equals mx plus b. And we're trying to identify m and b. So m equals, we already said, the change in the y over the change in the x. How much are we changing going from here to here? 1. That's a change of 1 over how much did we change in the run?
1.
So the slope here is 1. Now we could have substituted 6 minus 5 is 1 over 0 minus -1 is also 1. You can use your slope formula, or maybe you can find the change just the way we did. Change of 1 over 1. As long as you do rise, y values, over run, x values. Okay? So we now know we have 1 for our slope. Does anybody see the y-intercept? Casey told us the y-intercept is when you plug in 0, where do you end up on the y-axis? Right? Do you see it now? Who sees it? Raise your hand if you see it. Where's the y-intercept? Where are we plugging in 0 for x? Do you see it? Right here, right? We're plugging in 0 for x. When you plug in 0, what do you get out?
6.
6. So there's your y-intercept, 6. And you've written the equation. This one we didn't even have to do anything difficult because the y-intercept was very visible. Okay? Now, how can a person check to make sure that they've written the right function rule? Bella.
We could try it out. Plugging in on the
And which of these points will work in this equation?
0, x equals 0 and y equals 6.
Is that the only point that will work?
All of them.
All of them should work. So if you wanted to be sure that you wrote the right function rule, you just check maybe 2 of them. Make sure 2 points work, right? If you had time, you could check all of them. So let's just do that real quick. Let's plug in this point. When we plug in 0 for x, do we get 6 out for y?
Yes,
Is 6 equal to 1 times 0 plus 6?
yes.
So there's a point that works. What other point do you want to try?
1 7.
1 7? Okay, let's plug in 1 for, I'm going to erase so I have a little more room. 1 this time. Do we get 7 out?
Yes.
We do. It works. It should work for every single point, and it does, because we wrote the correct rule. So there you go. Is there a way we could simplify that rule, though? Y equals 1x plus 6. Carly. Sophia. You cannot have the 1, so say it without it. Y equals x plus 6. Good. We don't need the 1 coefficient, because it can be invisible for us. Right. Okay, we're going to do it again. Let's find the linear equation, or you could call it the function rule, for this set of points. Okay, so pause the video, take it down, and see what you can do. Okay, so we start with the model for a linear equation. Chad, what is that? Y
equals mx plus 3.
Good. So, x, y need to remain open to all the infinite points that are possible on this line. But m and b we need to find, right? So how can we find m? You're going to have to do this all by yourself. How would you find m, Jeremy? Actually, change in y over the change in x. So if you wanted, what would you use?
Well, the changes for y, the changes 10.
Oh, he's looking at this and saying he sees a change of plus 10. Plus 10. Plus 10. Does everyone see that change?
Yes.
So he's not actually going to use the formula y2 minus y1. He's actually going to say there's a change of 10 in the y direction. And what's the change here?
1.
Plus 1 plus 1, right? We're going to the right, so 10 over 1. So what is our slope, Jeremy?
10 over 1.
And we can simplify that and just say 10. So we have 10x, and we just need to find b. Now, does anybody see b in the table? Don't tell me that you see b in the table. Lexi, do you really see b?
No.
You're predicting it. She's such a smart cookie over there. She's predicting it. But I don't, what if I couldn't predict it? What would I do? What are you going to say, Lexi? What do you think it is? Who else agrees with Lexi? Look at, these are all your predictors. They're psychics. These guys are, no. How did you know? Lexi, how did you know?
Because instead of going to the right and to the left and subtracting.
She subtracted 10. So if we were to make another little column here, if I went one place to the left, what number would be in my x value? 0. And what would I have here? 6. Subtracting 10, 6. So she predicted it. Yay, good for you. Okay, so here's our y-intercept. Now, for those of you who weren't able to predict so readily, there is another way, and we wrote it in our rule box. If you don't know what b is, because you can't see it in that table, do we have any points in the table? We do, we have a whole bunch of points. So if we just plug one of those points into this equation, let's do that. Somebody pick a point. Pick a point, any point at all. Jimena.
36.
Okay, so she's picking this point, okay? 336. So look what happens. If we plug in 36 for y and 3 for x, we don't know b. How many unknowns do we have in this equation?
1.
So can we find it?
Yeah.
Yes. What is 10 times 3?
30 plus 40.
And 36 equals 30 plus b, so b is
6.
So that's a substitution method for finding b. If you're not into predicting the way Lexi did in half the class, you could use substitution. Because the goal of algebra is usually to get one variable, one unknown, and then we can find it, right? And that we then can find other things with that. So the equation, when we write it with the y-intercept is, let's say it together, y
equals 10x plus 6.
Isn't that the same y-intercept we had before?
Yes.
And the other one. Okay? So that's what you get to practice. What's that? Oh, yeah, that was